From an ISV perspective, sort of a special type of developer that makes a business out of driving their software to maximum number of users and platforms, they can leverage their efforts much more effectively. So they basically get a better return on investment on their developer efforts. And the last point is that you can reduce the number of artifacts that you actually produce in a given thing. So this goes to cost and it goes to quality of the software dominantly for developers. From the point of view of users and customers, if you look at the what do they get from a VM? Well, they don't actually deal with the VM. They just get some software from somebody and they have to deal with it. What do they care about? Well, they care about how fast is the software, how fault tolerant is the software, how can I manage and deploy the software. And so in at least 2 out of 3 of those aspects, I think they've gained tremendously in that we have seen greater availability and we have seen better manageability of software because of the ability to deploy and manage VMs effectively. Performance, as I said, I think that there's potential there. There's potential for a user to receive software that runs best on their workload, not best on some workload or set of workloads that the developer or ISV decided was the best case to tune. We're not there yet. I think we're getting there in VMs, but that's still a potential statement. So we might ask for the IBM's interest, and this is sort of for information of those people that don't know how IBM leverages Java in particular. Although I'll generalize and talk about virtual machines, certainly we have invested in other virtual machines historically. I think dominantly we invest in Java today. So we're invested in environments both as a support structure for our software portfolio as well as a way to drive value into our server platforms. So when we invest in the development of computational Veriflex or any other aspect of the execute environment, we're kind of the stakeholder to God for producing companies as well as the quality cloud tools. So there's a bit of a tension that you have to link the machine the same, so you've got to free answers from clients to our. So from my point of view, clearly we want to protect this investment. We want to make sure it gets the value. So that's meant to be interesting. The programming models we develop is really predicated on a lot of elements of virtual execution environments, and so as we go forward, we're going to depend more and more on some of these fundamental capabilities, whether it's in the time. Furthermore, all of our management tooling, infrastructure, and deployment depends on a lot of the sectors as well. Continues today. We see in the PERCS project, we see in other projects that you'll hear about in the next couple of days that IBM is still very much interested in fostering that community within and outside IBM. So a few problems. So again, this isn't an exhaustive list. This is sort of my personal list, if you like, or a few items that I've discussed with colleagues in IBM. So I had to put performance first. Virtualization has a cost, and this is something we just need to understand. Of course, as we've had dramatically improving processor speed and memory capacity and reducing latencies and increasing bandwidth, a lot of this performance penalty has kind of disappeared magically because we haven't seen it. We've had the hardware kind of pick up the slack for us, which I think is dominantly why we've seen wider adoption of these virtualization techniques, because the cost is, while still there, is not as apparent to the end user. Of course, there are many environments, and I'll talk about some where small devices, for example, where some of those problems still exist, and we still have to work pretty hard to deal with that. So performance is, as I said, in theory, is kind of a solved problem in the sense that we all know how to do dynamic compilation, we all know how to do garbage collection, but there's varying qualities of these in different virtual execution environments. So then going back to the user who's got to deal with 2, 3, maybe more VMs sitting around, well, they're going to get variable quality from the different VMs. That's an investment question. Some people are able to invest a lot more. Maybe some platforms are a lot better than other platforms, etc. So that non-uniform quality is an issue because you end up having nasty performance problems for a particular application when you code in a particular programming language or when you're on a particular platform. And there's also sort of common blind spots here about dynamic compilation is kind of notoriously bad for startup time. We still have sort of major footprint problems because of the bloat of code on top of these virtual machines. So, these are common issues that we still need to solve. As I mentioned, device support, I think that, developing a lot of these virtual environments on really fast PCs with lots of memory is great, but you know, when you try to take them down, and which typically the way you do it is you translate those down into small devices, you find there's all sorts of problems. So typically we don't really design these runtimes for small and heterogeneous memories or for slow processors. And slow being a relative term, of course, you know, maybe only 400 megahertz or something like that. The last one is, or the last one on this chart is about how virtual environments interact with native environments. So this has also traditionally been a blind spot for these virtual environments. Is you figure that, you know, programmers are going to code almost everything in Java, or they're going to code almost everything in C# or everything in Python, which might be true. But increasingly, people want to mix these languages. They want to use the right tool for the right job, and they also want to interact naturally with a lot of native code, either for performance or because there's libraries out there, for example, scientific libraries or device support libraries that they don't even own. You know, they're just native code. And so we don't make that easy. We've never made that easy to cross between virtual and native. And when I say that, I mean a bidirectional statement. You know, calling native code as well as taking these virtual environments and embedding them in native software. And so the word embedding I'm using to say that the native software can actually rely on the behavior, can predict the resource utilization of the virtual environment and control it. And potentially, of course, share resources across the virtual real environment. So that, I don't think, is a very well solved problem at all. It's again, been a blind spot for us, and I think we need to focus pretty hard on that. Interoperability is sort of a similar story. I think that, you know, this is one area, interoperability between programming languages, this is that the CLR has brought to light and actually produced some good solutions for. But really, there's some choices here. You know, there's the choice of saying that we're going to create a common virtual machine that many different compilers can target, or there's the other choice that says, you know, there are going to be multiple virtual machines in the world. Let's learn how to make them work together. Okay. And so from an end user perspective, it doesn't matter. Okay, they've got multiple programming languages. They want to make them work together. They want good performance. They want reliability, etc. From an economic perspective, it may not work out that we're all going to be able to share one VM. You know, I think that's probably an optimistic outlook. So interoperability is something we still need to work very hard at. And the focus that I'm taking is back up and let's look at what the programmer's trying to do. The programmer's trying to use the best tool for the job. They've got, you know, they love using Python in this particular instance. They love using Java over here. They love using C++ over here. Let's allow that. Let's make it perform well and let's make it usable. And they don't particularly care how it works underneath the covers. And then the last point here is about complex behaviors. So, you know, while we all love dynamic loading and we all love dynamic behavior and runtimes, and it gives us all the freedom in the world as implementers and as programmers, it's damn hard to debug problems. You know, and so when you are out in the field and you've got a problem that's, you know, shows up on Tuesdays, sometimes, it's quite difficult to understand because you've got dynamic compilation that happens in different patterns. Decisions are made differently based on environmental differences. You know, the heap state is different, causing garbage collection to behave differently. You've got multi-threading happening in the environment. So this behavior, while applications are complex enough, the dynamism inherent in the virtual execution environment is adding to the problem. Okay. It's not necessarily to say that we don't want this dynamic behavior. It means that we've got a problem to solve. We've got to have better tooling. We've got to be able to represent this complex behavior back to the programmer, back to the user in a way that they can understand and infer how to fix their problems. And finally, performance analysis and tuning can be, you know, an altogether more complex job than it has ever been before, again, because of the dynamic behavior. So as I'll say in a minute, I think we've got an opportunity to fix these problems by introducing much more sophisticated tooling on the basis of having rich type and structural information available in the runtime. So opportunities. So this is touching on some of the same points. I think, you know, while I say there's a problem with multiple virtual machines and programming languages, I think it's absolutely a positive, and you know, it's a step forward to allow programming language choice. Absolutely. You know, I think there's a healthy divergence of programming language choices out there, and I think that's something that we all want to encourage and nurture. On the other hand, going back to a couple of points I made, we want to make sure that there's a fairly uniform, reliable quality in the underlying runtime that people can rely on, and that these languages will interoperate in a reasonably predictable way over time. Okay. But having said that, I think that the opportunity for virtual environments is that now that you've factored the runtime, you're taking care of some of the hard problems, you're giving language implementers and language designers, all together more freedom to innovate in the language and innovating implementation. So that's a positive, and it's an opportunity, I think. So I mentioned the debugging capability of enhancing debugging and availability capabilities. I think we've scratched the surface on what we can do with tooling in this space. Again, because you have such enhanced control over the execution of your programs, you can actually improve availability through better checkpointing mechanisms. You can improve debugging through, introducing more adaptive behavior in the program to improve fault tolerance, to diagnose failures, and so on. The third point is about what we see as a trend in our programming model toward more distribution in the programming model, toward more service-oriented interactions, which essentially means transparent distribution points in your program. That's great from the point of view of flexibility of deployment and integration and the ability to take your code and run it on a diverse set of hardware. It's really bad if you're going to introduce these potential distribution points and every one of them costs you a fortune. So going back to the performance point here, I think it's actually a showstopper. Nobody's actually going to build their programs as an interacting set of fine-grained services if it costs them a fortune to do so. And that's always been a problem of the distributed programming, is that the distribution points have always surfaced up to the application programmer because they cost a fortune. You have to have coarse-grained interfaces, you have to marshal things in and out, et cetera, et cetera. So this is an opportunity, I think, for a virtual environment to ensure the performance of these service interactions despite their frequency or the granularity of the interaction. Okay, so that comes down to dynamic proxy generation in cases where you need to do distribution, but also things like dynamic interface specialization where the services reside on the same machine or in the same process.